Okay, so assalamualaikum and hi everyone. So for this presentation, I will briefly introduce the hydrological cycle, which is also known as the water cycle. So, what is hydrological cycle? So, hydrological cycle, or known as a water cycle, is a natural process that explains on how the water moves continuously on Earth. So it also involves the movement of the water between the ocean, land, and then the atmosphere through the process such as macam evaporation, cloud formation, and then rainfall. So the cycle is very important because it helps to regulate the Earth's climate and ensure the continuous supply of the water for the living organism. So, okay, for this slide, I will briefly explain about the main process in the hydrological cycle. So, as you can see in the picture, the water evaporates from the oceans, river, and land due to the heat from the sun, and then the water will vapor and then cools, and then it will undergoes again the condensations to form the clouds. And then when the cloud become heavy, the precipitations process will occur as rain, and then the rainwater will flow as a surface runoff, or it can infiltrate into the ground or the groundwater, and then it will return back to the ocean. So this continuous process is known as a hydrological cycle. Do you know that where is the water on the earth? So the hydrological cycle is a continuous process that describes how the water moves between the ocean, atmosphere, and land through the different physical process. So in this cycle, the ocean actually it acts as a main reservoir of the water, which is it store approximately 97% of all water on the earth. This slide, I will present about the overview of the process, which is I will explain a little bit of the process that occur in the hydrological cycle. So as you can see in the picture, the water is transferred from the sea or the land to the atmosphere by the evaporation. Here by the evaporation and transpirations, and then from the atmosphere to the land by the sea and by the precipitations, which is it will fall as a rainwater ataupun snow, and then the water will infiltrate in the soils and percolates further into the ground to become the groundwater. And then it will traverse from the land to the oceans, to the ocean back by the rivers. So in the process, it causes the surface runoff and as a groundwater seepage in the process that called the through flow, where the water will evaporate into the atmosphere again.
Hello, my name is Daniel and my matric number is 214,073. Okay, now let's look at evaporation from the ocean surface. Evaporation is the process where liquid water changes into water vapor, rising into the atmosphere. The ocean is the largest source of this evaporation and it plays a huge role in the water cycle and climate regulation. There are three main factors that affect how quickly evaporation happens. The first is sunlight. When the sun's energy warms the ocean surface, more water molecules gain enough energy to escape into the air. That's why evaporation is stronger in tropical regions where sunlight is very intense. The second factor is temperature. Warm water evaporates more quickly than cold water. Why? Because higher temperature gives water molecules more energy, making it easier for them to break free into the atmosphere. That's why evaporation rates are higher in summer compared to winter. And the third factor is wind, because wind moves moist away from the ocean surface and replace it with dry air. This keeps evaporation going because the air right above the water doesn't get saturated. So, stronger winds usually mean faster evaporation. So, in a summary, sunlight provides the energy, wind clears away the vapor, and the temperature controls how fast molecules escape. Together, these factors drive the continuous evaporation from our oceans, fueling clouds, rainfall, and the global water cycle. Thank you.
Assalamualaikum and hi everyone. So today I would like to present about the conversation over the ocean and cloud formation in the hydrocycles. They are important process that under the hydrocycles. So they explain on how the water from the ocean change to the clouds and then it returns as a rain. So let's move on to the first step. The first step is the sun will hit the ocean. So as we know, the sun will provide the heat energy to the ocean surface. So the ocean surface will absorb the heat of the water and then it will become warm. The warm seawater will change from the liquid to the water vapor. This is called the evaporation. As we know, the ocean is the main source of the water vapor in the atmosphere. The warm air is containing the water vapor into the atmosphere. After that, air cools at higher altitude. So, when the air cools to the points, the water vapor will change to the water droplets and the ice crystal. This is called the process condensation. That cloud formation above the sea. How it happens? So it happens when the tiny water droplets gather around the small particles and then such as the sea salts. When many droplets combine, the ocean will form above the ocean. The last step is precipitation. It means the rains will occur. So how it happens? It happens when the droplets become heavy and large, so it will fall down as rains. This completes as a part of the hydrological cycles. So let's move on to the conclusion. In conclusion, the sun will hit the ocean. It's called the evaporation. And then the warm air will rise and cool. It's called the condensation. The final is the clouds will form above the sea. It will happen the rain. So these are important part of the hydrological cycle. So
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syahri Gudosli and my metric number is 215904. So I will present to you about two things, which is the precipitation over oceans and coastal area, and second, importance of rainfall to the ocean circulation. So let's go for the first topic. So into the introduction for precipitation is precipitation over the ocean and coastal regions is a key component of the global hydrological cycle because it controls how water moves between the atmosphere, ocean, and also land. Precipitation over oceans dominates the global hydrological cycle by recycling evaporated water back to the sea, while coastal precipitation acts as a critical bridge connecting atmosphere processes to land-based water systems. Together, they ensure the continuous movement and balance of water across Earth's surface and atmosphere. So now let's move to the first precipitation over the ocean. So there are three components. First is main source of global rainfall. About 70 to 18% of Earth precipitation falls over the oceans, since they cover most of the planet and provide continuous moisture through evaporation. Second, evaporation precipitation balance. Warm ocean surfaces promote high evaporation. Water vaporizes, cools, condenses, and falls back as rain, maintaining the ocean atmosphere water exchange. And third, role in atmospheric circulation. Oceanic precipitation is strongly linked to large-scale systems such as the Intertropical Convergence Zone (ITCZ), monsoons, and tropical cyclones, which distribute heat and moisture globally. For the coastal areas, there are three components also. First is transition zone influence. The coastal precipitation is influenced by both marine and terrestrial processes. making it more variable than open ocean rainfall. Second, freshwater input to land systems. Coastal rainfall contributes to river discharge, groundwater discharge, wetlands, and estuaries, linking the oceanic and terrestrial hydrological cycle. And lastly, land-sea breeze interactions. Daily heating differences between land and sea can trigger convective rainfall, especially in tropical coastal regions. Now we move to the importance of rainfall to ocean circulation. So for the introduction, rainfall precipitation plays a crucial role in ocean circulation by controlling seawater salinity, density, and large-scale water movement, which are the key components of the hydrological cycle. So there are four importance of rainfall to the ocean circulation. Firstly, regulation of salinity. Salinity differences helps create horizontal and vertical density gradients that drive ocean circulation. Second, control of seawater density. Ocean circulation depends on density differences, which are influenced by both temperature and salinity. Third, influence on thermohaline circulation. By freshening surface water, rainfall can slow or modify deep water formation, especially in the high latitude regions. And lastly, climate and ecosystem impacts. Rainfall-driven changes in ocean circulation influence climate systems such as monsoons and El Nino Southern Oscillation (ENSO). So that's all from me. Thank you.
Water returns to the ocean mainly through rivers, groundwater flow, and melting of ice. In oceanography, this process is important because the returning water carries nutrient and sediment into the ocean. This input can affect seawater salinity, ocean circulation, and also support marine life and global climate regulation. Next, surface runoff from land to sea happens when rainwater is not absorbed by the soil and flow over land into rivers and eventually the ocean. This runoff transport nutrient, organic matter, and sometimes pollutants. While nutrient can increase marine productivity, excessive runoff may cause problems like eutrophication and low oxygen levels in coastal water. Overall, the hydrological cycle is a natural system that links the atmosphere, land, and ocean. In the context of oceanography, the ocean serves as the primary reservoir of water and the primary source of evaporation. The process of water transfer between land and sea not only maintain the global water balance, but also influence climate, salinity, ocean current, and the health of marine ecosystem. Therefore, the hydrological cycle is fundamental to the stability of the Earth system and the sustainability of aquatic life.